Hello, so today we are doing this problem called shortest bridge. It's a medium difficulty problem on Leetcode. So the problem says we have 2D binary array and we have two islands. We know that there are two islands, and an island is just a 4-directionally connected group of cells that have the value 1, such that it's as much as we group as much ones as we can into one island, and we have two of those. And we might change 0 to 1 so that we can connect two islands together to form one island. And we want to return the smallest number of zeros that we can flip so that we can turn the two islands to 1. So let's take the examples that we have here. So the first example is 0, 1, 1, 0. And so for this example, if we can just turn this one into 1, and now we have one connected component. So before we had this one as a separate connected component and this one as another separate connected component. So remember, this is 4 directional is only, so it's only to the left or right or up or down. Those are connected on the same diagonal, are not considered connected, and so this one is considered a separate component and this one a separate component. But if we turn this 0 into 1, we have one connected component, and so the minimum number of zeros we can flip is either this one or this one. And so the output here is equal to 1. For the other case, which is 0, 1, 0, 0, 0, 0, and 0, 0, 1, this case here. So this case, we have this connected component and this connected component. So the minimum we can flip is 2 zeros, either by doing this, and we get one connected component that goes from here down and then right and then down. Or we can also do something like this, where we turn this into 1 and this into 1. Like this. And now we have one connected component that goes right and then down, all the way down. And so the result here is, the output here is 2, right? Now let's look at this other example here. So for this example, we have this border here that is a separate connected component, and then we have the one in the middle that is a connected component. And so the minimum number of zeros that we can flip so that this entire thing can be one connected component is just this one, so that these two are connected and the entire thing becomes one connected component. Or we could also flip this one. Same thing, it requires just one flip. Or we could flip this one, and that's just one flip. You get the idea. We can do it different ways, but the minimum number we can flip is 1. And so this is the idea. So you can notice here that essentially what we are doing is we are looking for the minimum distance between the two connected components so that we can so if we find the minimum distance between these two connected components, that means that minimum distance is the number of zeros that we need to flip. And the minimum distance, of course, the minimum distance that contains only zeros, right? So one way we can do this is using just brute force. Let's just think about a brute force way to do this. So we can just create S1 that contains the coordinates in the first connected component. In the first connected component, or let's say the first island. That's what the term here. And we can create another C2. We can fill these up with DFS, right? And once we have these two, we can just go through all of them. Go through, like, traverse, go through. So say for ij in, let's say we can go through the coordinates in C1, and then go through the coordinates in C2. and have some kind of a min distance, right? And every time check here if we can achieve a better distance between each, like take each element in the first connected component and calculate its distance with the element from the with all of the elements from the second connected components and take the minimum. So just do the distance between I1 between, let's call this just C1. So these are the coordinates of the first connected component and this in C2. So take the distance from between C1 and C2 and have some kind of min distance value, initialize it of course here to some max value, say max int or something, max float or max int or something, and then our min distance would be just, we minimize it with this distance. So this is really just brute force on a brute force solution for this. It probably may get TLE, but it's a good exercise to cut it up and see what it looks like, right? And so filling the first connected components means just starting from the first one that we can find, and then doing some kind of fluid fill. And every time we encounter a 1, we add it to C1, and we replace its value with some whatever -1 or something, so that we don't add it to the second connected components, and then do that also for fill also C2, and then do this, and at that point we will find the result. Now how can we find the distance between two things, C1 and C2? So let's say C1 is just I1, has the coordinates I1 and J1, and C2 has the coordinates I2 and J2. To find the distance between the two, it's just the absolute value of I1 minus J1 and plus, minus I2, the absolute value of J1 minus J2. And we need to do -1 so that we don't count the coordinate value itself. And that's pretty much it. Now, let's code this up. So we know we have two connected components that we need to fill up. So let's just construct our list for them, and then let's go through the grid. So we go through the grid using range of length of A, and go through the columns after that. Columns are in 0, and then like this. And if we find one that has the value 1, so that may be the start of a connected component. That's the start of a connected component. And so we need to do DFS on RC, and we need to pass whatever connected components we need to fill up. So the first time we will fill up C1. So let's just use an I variable that will allow us to know which one of them we are filling up. And so first we fill C1, so let's assign it 1. So it's C1 if I equal to 1, else it's C2. And so when we fill C1, we need to do I plus 1 so that we can fill C2 next time instead. But when our I becomes bigger than 2, that means we are done. That means we are already filled C1 and C2, and so that's all we want. So we need to return C1, C2. So let's call this function fill components, or fill connected components. So this will just fill the components that we need. So we need this, and it will return just the two connected components filled with the coordinates. And here we can just say return C1, C2. And so we have that, and so we need to write a function for our DFS. I'll do that. So I, J, and then component, and that's pretty much what we need. But we also need to call that function here in the. And so once we have these two, what do we do next? So we said once we have them, we need to do this loop, right? And so let's do that loop. So we would have I1, J1, and then I2, J2. And we will need to have some kind of result or min distance. let's just initialize it to the max value we can, so that's float of inf. And so we take min_dist, which is equal to the minimum of min_dist, and the new value, which is the distance between that we said here, which is just, let's just take the definition that we said, and at the end we can just return that. That's pretty much it. We just need to define our DFS, which just adds the connected values to that have value 1 to C1 and to C2 to whatever components is passed here. And so we need to have we need to just first add the component here. So we add the coordinates, and then we need to go one thing. So I could have visited set that I add ij to, but just to not use an extra like space, I'm going to just replace the value with -1 so that we don't use it again. And now we need to go through the neighbors, right? And so it's 4 directionally, it's only the 4 direction, up, down, left, and right. So let's use this for the delta that we need to add every time. So we need to have, or let's actually just say these neighbors like this, and we would have, one of them is i+1j, so this one is for going to the right and then going to the left, and then other one is for going down, and the other one is for going up. And then we need to make sure that our boundaries are correct, so that it's still in the boundaries. So that would mean just checking this. And then we need to check that it's a valid, like it's a value 1. It's in a component. It's not 0, because the islands are just contain only ones, and so we need to check that this is equal to 1. And if it is, then we need to do DFS, and we will add it to the component when we do DFS. And that's pretty much it. So let's run this. So it works for this case. Now let's see for the other cases that we have here. Okay, so it didn't work for this case here, where it should have returned it 2. Let's see. So it's still returned infinity here. Maybe this is, let's just, shouldn't be a problem, but so this computation is correct, it's valid. Now let's look at this. Did we make a mistake here? Let's just make this 0. So if I equal to 0, and then we add i+1, and then if it's equal to 2, we can return. So we need just 0, and then it will increment to 1, and then second time it will increment to 2. And then if I equal to 0, we pass C1, otherwise we pass C2. And we check that is equal to 1, and here we assign. It's good. Okay, that also seems good. What did we do wrong? Okay, let's print C1 and see what is the problem there. Print C2. Should be after this. So it seems like both are not. C2 is empty. That's the problem. Is that our C2 calculation didn't work somehow. So we do increase I, and so maybe this didn't. So yeah, so we pass here only once for some reason. Okay, let's see here. Okay, so we do pass there multiple times, except so we get only one of them. So seems like we did set one to -1 by mistake. Okay, let's make this a little bit clear by using 0, 1, by using dx and dy in 0, 1, and then we have 1, 0, and then -1, 0, and then after that we have 0, -1. So these are the coordinates, and then ni and nj would be, these are the deltas, and so would be I plus dx and then j plus dy. Okay, let's see our DFS. So our DFS is still called initially just once. And this, it's on this, so this here, it should be called, this is this case here, right? 0, 1, 0, 0, 0, so it should be called for this last one, but it wasn't. And the last one has the value -1, so we are making a mistake somewhere here. One thing I'm going to do just to make sure this is not messing up the yeah, here's the error. I'm checking ANG. I should be checking NI and J. Sorry about that. Yeah, typos are the worst. Okay, so now we see that this one is detected and it's not like wrongly set to -1. And now we have two connected components, each with the value of with this value and then this value. And let's remove our print statements here. And this should Okay, so we have the correct solution. Now let's submit. So you can see we have time limited except time limit exceeded here at case 80. This is what I expected. Like when the values start getting really large, this solution is no longer works. And so basically, if we look at the time complexity for this solution, it's really brute force. And so you can see here we are doing O of R by S, just this loop. And then we are doing a linear DFS that also goes to these. So it's like O of E plus V. So it's around like both of them. So R plus C. And then we have also this, but this is also just R multiplied by C at most. And so overall, this is like the time complexity overall of this entire algorithm here. It's squared, right? So this is really not good, and yeah, it's not surprising that we got time limit exceeded. Now let's see how can we improve this solution. So one way to think about this problem is, so we can't really use brute force. So let's see how can we use something else. So one idea is to use something here where we have let's say grid like this one with values here already set, and the empty ones are just with the zeros. So what we are going to do is we are going to take one of the islands, put 2 in it, with the DFS of course, doesn't matter which one, and then start expanding using BFS, expanding that island to all the nearby zeros, level by level. So level by level, fill the zero values with the previous one. You can consider it like a color. So 2 is a color, 3 is a new color, and so going from 2 to the next level, fill it with the next color, which is 3. And then go another level to the nearby zeros, fill them with the next level value or the next color, which is 4, and keep doing this 4, 5, 6, and maybe 7 even. But as soon as we hit any new 1 value, that means we hit the new island. And since we are doing BFS level by level, the first 1 value that we hit, that's the shortest distance to the next island. And that's exactly what we are looking for. We want the short distance to the other island, because all we need to do is fill that short distance with 1 values by flipping the 0 values in that short distance, and that's the answer, right? And so how can we solve this problem? So the first thing we need to do is paint this island with values too, right? So the first step is find one of the islands, 2, paint all its values with 2. That's what we said here, right? That's what we did here. Then the third step would be to, once we did that, just keep expanding level by level. Keep expanding here, keep expanding level by level, and for each level with color equal to 2. For each level, paint with color equal to color plus 1, right? To previous color plus 1, right? Let's call this step expand, right? And then as soon as we hit any cell with value 1, which means we hit, so this means we hit the second island, then return color minus 2. That's equal to the min distance, right? Why is that? Because we started from color 2 and kept adding 1, 1, 1 every time we went to another level. So the distance would be just from this -2 for this color, because after that we just kept adding, and so that's the minimum distance. And we can just return that. And yeah, return it. And that's pretty much all we need to do, sorry. And return it. And so that's pretty much all we need to do. So let's code this up. So the first step we said is find and paint the first island. So let's do a method that does that. So let's say find and paint first island. So let's do that. So def find them, and this is step 1. Okay, we need to pass the grid, and then after that we need to paint all its values with color 2. So we need to do that during the paint. So here also do 2. So this is 1 and 2, and also paint all its values with color 2, right? And then after that we need to expand. And so to expand, what we are going to do is we need to do some for loop. So yeah, let me just do this later. So expand, and let's call this third. So this is our third step. And then after that we will find some distance that we need to return. And what should we initialize our distance to? So the problem says that the answer is guaranteed to be at least 1, and so the lowest value less than 1 is just let's call this res instead. That's just 0, right? And so from there, while we didn't update the value res, keep going, right? And I will fill that up later, but let's do this paint the first island, find and paint the first island. And so to find that, we'll just go through the grid until we find the first one that is equal to, that has value 1, right? And so if a of ij is equal to 1, then we are going to start painting from that position. And once we paint return true, then that means that we found the island. And so at that point we just need to return. And so we need to define the paint function that does aij and returns true when an island is found. And this one uses also DFS. And so what do we need to do? So we need to we know we need to color it with, also paint all its values with 2. So with color 2, so that's what we are doing here. So we need to paint it with 2, and then we need to visit its neighbors. So that would be visiting I plus 1 j, I minus 1 j, ij minus 1, and ij plus 1. And we need to call DFS on them. And we need to make sure that if it's invalid, we need to just exit and not do anything. And so checking if it's invalid, we need to check an I, length of A, like we did in the previous solution. And so this is actually I. We can do the check here, whichever you want, both are the same. So I'm just going to do it here, J length. So it will be called and then it will exit here. So if I want when it's not valid. So if I is less than 0, or j is less than 0, or if I is bigger or equal to this, so it's invalid, or if j is bigger or equal to this, then it's also invalid, or if the value is not 1, right? If the value is different than 1, then that means it's not part of this island anymore. Either that it was already set, or the value is 0 and we shouldn't set it. And so if j is different than 0, in all of these cases we need to just return false and say we didn't find anything. And so it's actually not DFS here, it's called paint. And if we pass it here and set a value to 2, that means we did find an island, so we just need to return true here. And so now we did the first step, which is this one. Now let's do the step where we continuously expand. And so we need to define some function that does expand things, and so that would be expand here. And so it starts from this and it gets given a color, and what it does, it just goes to the nearest ones on its level and sets, so it just goes to 1, like no, so basically it just goes to a cell and check if its value is 0, and it sets its color to the next one, right? So this one is previous color, and what we are going to do with that is actually let's leave it not set yet and we'll come back to it. So this one, it should just set the color of cell at ij to next color, which is equal to this plus 1 if the cell was empty. Because if the cell was not empty, let's say either the value is 2 or the value is the new one, then we want to do something else. So if the value is 2, we don't want to do anything, it's already set with the right value that it needs. But if it's a new, if it's the other island, then we want to finish because we found the solution. And so only if the cell was empty that we want to change that one. So here, let's go through. So basically, we need to go through all of them and find those that are that needs to be expanded. And so at every time, the first here we need to expand the neighbors of all those that have value 2. Here we want to expand the neighbors of all those that have value 3. Here we want to expand the neighbors of all those that have value 4. So that means we need to keep track of this value 2 and 3 here and 4 here. So let's call that value distance, the current distance. And it starts out as 2 because we already filled with 2. In this step here, we already filled with 2. And so that one starts out as 2. And so we go and any cell that has value 2, we need to fill its neighbors with value 3. And any cell that has value 3 here, we need to expand its neighbors with value 4, right? So that's what we are doing here. And so we need to go through J. And we need to check if the value is distance, current distance. Then we need to fill the neighbors, right? And so that means expanding A, the neighbors Ni and J, and the current distance. And that's what would be the previous color, or let's call it the current color. That would be more accurate. So the current color now for the neighbor is the previous color, so that it would be set to the previous color plus 1. Because when we are here, we want to set them to 2 plus 1. When we are here, we want to set them to 3 plus 1, which is 4. And so we pass the current color, and we want to do that for all Ni and Nj in I minus 1. This basically, actually. Let's just copy it. And once we do this, let's now write our expand. So our expand first checks if it's in the boundaries. If it's not, then at that point we don't wanna go there. We just want to return. Except we don't need to do this check because the value would be 0, right? We'll check that later. So if it's not in the boundaries, then we need to just return false. We didn't expand. And so actually what I want this expand to return, so it returns true if it hits the new island. if it hits the other island. So it will keep returning false for us unless the value in it is 1, which means we hit the other island. And this is basically equivalent to the value is in the cell is 1. If it's 0, we will just keep expanding, but if it's 1, that means we hit the other island. So here we will need to stop. And so what we need to do here is this one will need to return if it's equal to 1. But if it's equal to 0, then we need to fill it up with the new color, right? So if it's equal to 0, then we need to fill it with the new color, which we said is equal to the previous color plus 1. Okay. So now we have expand, and it returns true when it hits the other island, right? So we need to check here if any of these return true, so that we can do with Python with any. So if any of these is true, then that means we hit the island. So that means we found the shortest distance to the other island. So at this point we can just update our result so that it becomes the current color -2, which is what we said here. As soon as we hit any cell with value 1, which we do return true for it when expand returns this, then return color -2, because the 2 is because we started out with the color 2, right? And so this while not res will change as soon as res becomes more than 0, which would be the case when we get here. And so we return res, right? And so let's just run this. So yeah, we need to pass a here, and basically here the first step here is find the first island, paint it with 2, with the color 2, which is this, and then in this, and that's this entire code here, and then we went through all the nodes, in the entire grid, to find those with the current distance, which first it starts out as 2, and then we keep expanding, and then we add the previous color plus 1 each time until we hit the other island, which we detect by returning true with expand. And when we hit that, that means that we found the shortest distance, and so this while condition would be false, and we'll return the solution, right? So let's run this. So we have time limited. That means we have a mistake somewhere. Yep, so it's NI here. I put N by mistake. Okay, let's verify where is the mistake here. So actually, the equality to 1 here is already checked by this. So so there is a mistake here actually. So we can just check this, and when we find the island, we return. But here, if it's different than 0, that means it may be equal to 1, and that's exactly what we are looking for. We are looking for 1 value. So what I should do is different than 1. Because if it's different than 1, then it's maybe 0 or 2. Zeros are not part of the island, so we don't want them. The values that are equal to 2, those have already been considered, so we don't want these 2. And so yeah, that was a mistake there. So paint needs a Okay, so this one is correct now. This one should be good. Now let's see the other ones. Here we check if the boundaries are not valid, then we return false. If the value is 0, we assign the previous color +1, and then we return this. That one is good. So our res here, it starts out as 0, so this is true. And then we go through I and go through J, and we check if it has the current color. The problem is we are never updating the current color, but we should. At each level, it should increase by 1. So our current color here should increase by 1. Otherwise, we will just paint everything with 2s, and that's not what we want. And so our res will never be updated. It will always be 2 minus 2, which is 0, and so this condition will always be true. So that was the mistake. Sorry about that. Okay, so let's submit. So this solution passes. So that was kind of a combination of DFS to paint, and then BFS kind of with this expanding here. We just named it differently. But this problem actually can be solved more directly using DFS and then BFS. So I'm going to write that quickly here. So it will be more clear here with how BFS is written. So same thing, we want to find the first island with the DFS, and so we are just going to write DFS here to find the first island. But we are going to do something different. Is that we are going to, so first is we find the first island using DFS and put all its values in a queue. And essentially what we will be doing is that when we find all the values for this first island, we will put them in a queue so that we can traverse level by level until we hit the first island from the other side. But we will explicitly add them to the queue. So we will pass a queue here, and we will pass a visited set so that we don't visit multiple times like we usually do with DFS. And before calling out DFS, we are going to create our queue, which is the queue that we will use for our BFS. And so here we are going to start doing our BFS. And then our DFS will first do the same thing, check the boundaries. And we want also to go through only the values that are equal to 1 so that we can find the first island. So this is find the first island and put its values coordinates in queue. So if it's equal to 0, or if it's already visited, in all of these cases we don't want to process it, and so we want to just return. And then if it's let me just shorten this, makes it queue. Then we want to append ij to the queue so that we can do the BFS from all the values of the first island. And then we are going to add it to the visited set so that we don't visit it again. So let's call this add ij. Then we are going to go through the neighbors in the same way we did before. And then we are going to call DFS on that, so in I and j, and we need to pass all the required parameters. And now that we have that, now we'll start our BFS here. But one thing we need to do is we need to check. So for we need to find the first island, right? And so let's just have a boolean here that checks if we found the first island. So false. And then we need to go through the entire grid to find the first island, right? And so the first time we find the first one, that's the start of the new island. J equal to 1, that means we can start our DFS there, and we need to pass the queue, and we need a visited set, so and we need to pass it here, and once we do the DFS there, that means we found it, and we need to break out of our loop. And also when we break out of this loop, it will go to this loop, so we want that loop also to break. And so we would break here. And now that we did this, we found the first island. Now we are going to do while queue and do our BFS. So here we already found the first island and put it in queue. So now we are going to get the size of our queue so that we can iterate through it like this. The other thing is we need to keep track of how many levels we want using BFS so that we can return that, because that's the shortest distance we are interested in. So let's start out with the 0, and okay, well, let's call it distance instead, maybe that's better. And now what we are going to do is we are going to pop from the queue, and to get from the front of the queue we are going to do pop left, and that way we will get I and j, and we are going to traverse their neighbors. And so we are going to get the neighbors in this, and then we check if the value is 1, that means we hit the second island. That means we should stop, and we should just return the distance so far. And so if aij is equal to 1, but one other thing we need to check is the boundaries. So we need to check that this is within the boundaries. And j, length of I of 0, and we need to check that the value is not in the visited set, because if it's in the visited set it may be equal to 1, but it's from the first island. But if it's in the visited set, that means it was visited by the first island, so that means it's definitely in the second island. And so we are going to check that it's not in the, because if it's in the first island, we are not interested in exploring it at all. It's already in the queue, we are already exploring it, so not in visited. Then at that point we'll check if the value is 1. Now if at this point the value is 1, that means it's a part of the second island, and that means we found the shortest distance, so we can just return it. Otherwise it's part of the path to the second island, so we need to add it to the queue so that we can explore it with BFS. And so we are going to add it like this. And since we just visited it for BFS also, we don't want to visit it again, so let's just add it to the visited set so that next time we don't go through it again. And so that would be pending it like this. Actually, I should add in I and j, that's the value. And here, since this means I went through the entire level, so now I'm going through the next level, so I need to increase my distance, right? So when I go to the next level, which is these here that are next to them, and I'm done, then I need to add 1 so that I can go to the next level, and I keep track of the distance, and so I need to increase it by 1, like this. And then at the end, when the queue is empty, and we didn't find the other island, that means there weren't 2 islands, which will probably violate the condition of the problem, so we can just return -1, which is a not existing value. So you can see here we use two things: DFS first to just find the first island, and then BFS to find the shortest distance from that first island to the second island. It's Q. Should add to a set. Okay, so that case seems working. Let's try with this one. So this one also passes, so let's submit. Okay, so that solution passes. As for the time complexity for this one, so you can see we did DFS first, and we do it at most once here because we just need the first time that we find this, but we might not find it until the last value. So this one is still of R by C, such that the R and C are the length of the number of rows and number of columns. And then we do DFS one time, and so multiplied by V plus E, which in our case here is just R plus C. And so overall it's something like this. And so overall it's around O(n) squared if we O(n) by M squared. So actually it's just this multiplied by R plus C overall. Because for BFS it's the same, it's R plus C, and so it's kind of a little bit better than the solution that we had before. Yeah, so that's it. And for the space complexity, we are using a queue and a visited set, and both of them will contain at most the number of cells, and so it's R multiplied by C also. Yeah, so that's it for this problem. See you next time. Bye.